Well, welcome also from my side, being a local mushroom here, and also happy birthday to EPFL and nature, apparently. So, first of all, it's a great pleasure to be here, and it's a great pleasure to be here on this day, and in particular also in this very session. A huge fan of the work that Jeanette and Fernando have done, so I get a real kick out of this. I want to talk a little bit about open science and benchmarks, obviously. But I thought I could just stand here and tell you why I think benchmarks is like a important future of science. But then I thought, well, we're celebrating open science, and so maybe I should first start from first principles on why I strongly believe in open science. And it's actually something that helps me also think through the challenges. And I don't find that so easy per se. Open science, as a term is very attractive, right? Who can say anything against open science? But if you look at the term, right, it's not really self-evident. Like, what is the opposite of open science? Is it just science, or is it closed science? And what's so bad about closed science? It's not so clear. It's not self-evident. I'll contrast that to another term that I find, much more self-evident, and that stopped me in my tracks when I first came across it. And that's evidence-based medicine, right? And probably you have heard of evidence-based medicine, and if you haven't, then you're probably like me. And you're like, what? Evidence-based medicine, what is this thing, right? The first time you look at this term, your response is probably, what are you saying here, right? Do you mean to suggest that there is a medicine that's not actually based in evidence? And of course, that's exactly what it means, right? So in that sense, that's a better term. Indeed, right? If you're a practicing, physician, if you're a medical professional, you know very well what this means. You know very well that medicine, for the longest time, has not been based on evidence. That's obviously not good, and so you push forward this initiative of evidence-based medicine. And because it's very self-evident that medicine that is not based in evidence is not a good thing. So this is where now in the talk I want to introduce a book recommendation. I've noticed that the half-life of talks in terms of content is shorter than the half-life of book recommendations. And so I made it a habit to introduce a book recommendation in every talk. And this one in particular, I give very fondly. It's probably not too much for me to say that this may be the most important non-fiction book I've read in my life. It really means that much to me. I've read it 6 times so far. I know I'm going into religious territory there, but I can highly recommend it. It's by a scholar named Jonathan Rauch. It was published in 1993, okay? And it has recently been republished, and if you read it today, you know why it has been republished. So what I want to do, and the reason why I want to talk about this briefly, is I want to reflect briefly now on open science, because the issues we have there with this term. So what is it even that we're doing? Because Jonathan Rauch asked this very fundamental question in this book, which is, how do we as a society differentiate opinion from knowledge? And that's a very essential question, right? And as you know, humans have come up with many ways of doing that. And he goes through some of that in his book. But I can give you 2 examples, right? The one example, of course, is the system by which we do this through authority of power. My opinion is knowledge. It is the truth because I say so, because I'm in power. And if you disagree with this, then you're going to be jailed or silenced or worse, killed. And we unfortunately still can see life plays of this system in parts of the world. Another system that humans have come up with is religion, and the knowledge through authority from religion. So this is the truth because it's in this sacred book. And if you question that, then there's also a prison cell for you, or silence, or worse. In Europe, we've been fondly putting people up in stakes and burning them as a means of settling this disagreement. So that is not the ideal way. And what the point that he makes in his book, and which we all, of course, by now subscribe to without thinking of it, is that the best way of doing this is a system that he calls liberal science. I'm not sure if the word liberal is really necessary. And that he summarizes in this very simple sentence is the checking of each by each through public criticism, right? And this is fundamentally what science is. It's maybe not always what academia is, but it's certainly what science is, right? And in this game, there are two simple rules if you want to play. These are very important rules, right? Again, academia has invented thousands of rules, but in science, fundamentally, there are two rules. One is no one gets the final say, right? The book never closes. We always have to be accepting that we could be wrong. And if scientists find that incredibly hard, they find that close to impossible. I mean, they literally rather die than accept this. And this is why we joke that science advances one funeral at a time. It's because scientists just won't let go of that. The other one is that no one has personal authority. And it's also an extremely important rule, right? It doesn't matter if you're a 2-time Nobel winner. It doesn't matter if you're the president of the university. It doesn't matter if you're the richest person in the world. If some outsider or some first-year student comes in and convincingly to all of us demonstrates that you're wrong and she's right, well, then you, the president, you're wrong and this first-year student is right. So no one has personal authority. It's incredibly important. Otherwise, there can be no science. So this system of differentiating between what is opinion and what is knowledge has been just incredibly powerful, right? We've been incredibly lucky to reap the benefits of that. It's created enormous social wealth and also social health, with life expectancies approaching 90 instead of 30, what it used to be. And so that's why society invests heavily in it. That's why we, the government, the taxpayers, give us billions of Swiss francs or euros or US dollars, whichever currency you fancy, to do, not because we like it and we think science is good, but because we all think that's the best way of differentiating knowledge from opinion or opinion from knowledge and advancing. And so because we were getting this money to do exactly that, implicit with it, of course, comes this understanding that we do this at the most efficient way. And this is, of course, where the open comes in. So it's not because open science feels good. It's not even because science feels good. It's because we have this system since about 300 years, and we have demonstrated that it works, and that's why we're getting the money. And now we're being asked to do this openly, because we must do this as efficiently as possible, and everything else would be considered a waste of resources. So, recently I often travel in the train, and I'm lazy, so I never turn on a VPN or so, but I read Twitter because I like that. It's my source of insight these days, and I come across this incredibly interesting article, Adipose Lipid Turnover and Long-Term Changes in Body Weight, because I now work quite a bit on nutrition, and why are people getting more and more obese, and this is a major drag on health systems. Want to read? Click, this comes up. And now, of course, we could have all kinds of discussions why this is not necessarily an ideal thing. But in my view, right, without clear thinking, we can get fired up about this. My God, why do I have to pay $8.99, right? And why not $7.99? No, but why, why this? And, why do we have to pay? But I think there's good reasons, and we have heard of them this morning. And if you now think about what I just said, this is actually not per se inhibiting the science. I actually do not have a lot of issue with that. What I do have a lot of issue with is this sentence here, that if you can't read it in the back, says the data sets generated and or analyzed during the current study are available from the corresponding author upon reasonable request. So this is a fundamental violation of rule number 2, right? This person or these authors, are saying we have personal authority over this. We have personal authority to decide who gets to check us now. Because that obviously says there is a non-reasonable request that's possible. Right? So this is foul play in that sense. And I think this is where the thinking, I think, it really helps in terms of what do we actually mean by science, and which aspects should we really care about when we talk about open. So let me spend the final few minutes that I have on a particular system that I think aids this process and also makes it more open, exactly in that sense of that it leads to a faster checking of each by each. And that's benchmarks. So benchmarks is something that we see more and more in science, and I predict a kind of a benchmarkization of important parts of science. Now, before you get too passionate about this, I need to say, I know some people don't like benchmarks. I'm not saying that everything should be benchmarkable. There are important aspects of science that cannot be benchmarked. And one of the most important one is discovery, right? You're not going to discover CRISPR with a benchmark. That's clear. This is a question of exploitation versus exploration. You need to invest some of the resources in exploring and finding new things that you never even thought you were looking for. But then once you hit on something, it's actually quite good to exploit this relatively rapidly. And there, I think the academic system, science is currently not doing the best job it can. So you need two ingredients here again. You basically need to agree on a formalization of a problem. And then once you agreed how that problem should be formalized, you need to agree on how you're going to assess the solutions. And in my view, there's just so much waste in academia on people sort of trying to do the same thing, but not doing, sort of agreeing on these two fundamental steps. So if you want to know what a benchmark is, I mean, another way maybe to think of it is a sports event. It's not the best metaphor, but there the problem is, what is the fastest way for a human to go from A to B? And now you can formalize this in many ways. You can say, with bike, without bike, with car, and then even, without any tool, you can say, well, for 100 meters, for 200 meters, 400 meters, 42 kilometers. So this is the formalization, and then everybody agrees on how this stuff is measured. So, I'm working on numerous benchmarks. I want to show you here one, but just as an example, so we're working with the Swiss train network. They have the challenge that they need to be more efficient, right? And so, the question here is, how do we get as many people from A to B in as efficient way as possible? This is an optimization problem. And so one can come up with a benchmark in a particular simulation framework that's completely open source and that people can understand well. And then in my lab, for various reasons, not related to the trains, but for my own work, we built a benchmarking platform that we recently spun off. And so, it's an open source platform. And so this particular benchmark or challenge now, people can submit their solution and they submit code. And this is quite critical, right? They don't submit files or anything like that. They submit actually the raw code. And then we take the code and we execute it according to very clear specifications. And then people get, evaluated based on that in a way that's completely transparent. And what's funny about that is that even in 3 years, you can come and by click of a button, entirely reproduce the whole thing. And so we're trying to use that now in many different situations. That's just one that I want to show you here. The reason why I think this does actually make things much faster is because In the extreme case of the alternative, without the benchmarks, we are in this linear process, right? Where somebody comes up with some new idea, evaluates this idea on their own, publishes it, peer review, all this takes time. Then eventually someone comes along, reads it, has a new idea based on it, and so on. That's a very slow process. In reality, of course, there's many ways that we can speed this up, but it's fundamentally slow. The idea of a benchmark is to really bring everyone together in a sort of continuous fashion, having agreed on the problem formulation, having agreed on the evaluation, and then people can sort of work in parallel on this problem, and you can then spin out anything you want from that. Publications if you're an academic, live production, operationalization if you're in industry. But this obviously speeds up things rather dramatically. So this is actually not something fundamentally new. There are a number of really important benchmarks that have recently also even made The Economist or so. So the ImageNet classification benchmark is one of them. Those of you in machine learning know this very well, where this ImageNet data set and this corresponding conference and benchmark have led to this complete collapse of classification error of a technology that was almost practically unusable with a 30% error to something that actually in 2015, I think the Microsoft team did something that was better than human. And so this graph, of course, to some extent captures the angst in society about AI. 5 years, something is unusable, now it's better than human, based on a benchmark. And I could show many examples like that. And in my own field, or closer to my own field, the protein folding benchmark is another good example that could still be sped up by doing it continuously, but I think it's a good example. And I think we could find many more examples of doing this in an open fashion and in a parallelized way. So this is my last slide. This could have been the alternative title, making the checking of each by each through public criticism, so science, more resource efficient, so open, through problem formalization and automatic evaluation. But I'm not sure Luc would have accepted that title. But it's essentially what I wanted to show you today. Thanks very much.